SAM database. Local Windows credentials are stored in the Security Account Manager, or SAM database, as password hashes using the NTLM hashing format, which is based on the MD4 algorithm. We can reuse acquired NTLM hashes to authenticate to a different machine, as long as the hash is tied to a user account and password registered on that machine. Although it's rare to find matching local credentials between disparate machines, the built-in default named administrator account is installed on all Windows-based machines. This account has been disabled on desktop editions since Windows Vista, but it is enabled on servers by default. To ease administrative tasks, system administrators often enable this default account on desktop editions and set a single shared password. Given the capability of this attack vector, let's walk through an example. In this case, we'll attack the default local administrator account. Every Windows account has a unique security identifier, or SID, that follows a specific pattern. In this structure, the SID begins with a literal S to identify the string as a SID, followed by a revision level, usually set to 1, an identifier authority value, often 5, and one or more sub-authority values. The sub-authority will always end with a relative identifier, or RID, representing a specific object on the machine. Let's use PowerShell and WMI to locate the SID of the local administrator account on our Windows 10 victim machine. First, we'll determine the local computer name from the associated environment variable, and use it with the WMI Win32 user account class. To obtain results for the local administrator account, we'll specify the computer name through the domain property and the account name through the name property. The output reveals an RID value of 500 as expected. Next, we'll attempt to obtain credentials for this user account from the SAM database. The SAM database is located at C Windows System32 config SAM, but the system process has an exclusive lock on it, preventing us from reading or copying it even from an administrative command prompt. There are two potential workarounds. First, we could use the volume shadow copy server, which can create a snapshot or shadow volume of the local hard drive with VSS-admin, which is installed on Windows 8.1 and later. We can create a new shadow volume with the Create Shadow option, but this option is only available on server editions of the tool. The second approach, which will work on our Windows 10 machine, is to execute this option through WMIC, launched from an administrative command prompt. Specifically, we'll launch WMIC, specify the shadow copy class, create a new shadow volume, and specify the source drive with volume equals. This will create a snapshot of the C drive. To verify this, we'll run VSS-admin and list the existing shadow volumes with list shadows. Now that we've confirmed the creation of the shadow volume, we can copy the SAM database from it using the source path provided in the output. Although we have copied the SAM database, it is partially encrypted by either RC4 or AES. The encryption keys are stored in the system file, which is in the same folder as the SAM database. However, it is also locked by the system account. We can reuse our shadow volume copy to copy this file as well. We can also obtain a copy of the SAM database and system files from the registry in the HKey local machine SAM and HKey local machine system hives, respectively. Administrative permissions are required to read and copy. For example, we'll use the reg save command to save the content to the hard disk by specifying the registry hive and the output file name and path. Regardless of how we obtain the SAM database and system file, we must decrypt them. At the time of this video, the only two tools that can decrypt these files are Mimikatz and CredDump7. In this example, we'll use CredDump. First, we'll install the Python crypto library, and then clone CredDump from the GitHub repository with git clone. Next, we'll copy the SAM and system files from the Windows 10 victim machine to our Kali Linux machine. And use the pwdump Python script from CredDump7 to decrypt the NTLM hashes. We have successfully decrypted the SAM database and obtained the NTLM password hash for the local administrator account. In this section, we have executed this process manually to demonstrate the individual steps. However, many post-exploitation frameworks can automate this process as well. In the next section, we'll examine how Microsoft has attempted to mitigate the risk of this attack vector.